Today we are studying the chapter of dual nature of radiation and matter. What are the things which we are going to study in this chapter? We are going to study the further part of electromagnetic radiation chapter which we had studied in standard 11th. There we had studied about various kinds of wavelengths. What were the various kinds of wavelengths about which we had studied? And that in the which are available in the electromagnetic spectrum. In electromagnetic spectrum includes visible light, infrared rays, x-rays, then ultraviolet rays, gamma rays. These are the various types of rays which are available in our electromagnetic spectrum. Now further to this, what is the use of these wavelengths in order to produce electricity or to produce light effect? For the concept of producing electricity, what how light helps us to convert itself from one form of energy to another form, because electricity is of course another form of energy. First I will tell you the definition of photoelectric effect, which is the most dominant part of this chapter. Photoelectric effect says that when light of sufficiently low wavelength falls on the surface of a metal, electrons are being ejected. This phenomena is called as photoelectric effect. This can happen due to the light particle which is known as photon. The concept of photon comes from the word light in Latin or Greek language. They say light means photo or comes from the word photon. What are the properties which this photon has to follow when it falls on a metal surface or any other surface to give you the phenomena of photoelectric effect? A phenomena of photoelectric effect expects certain properties. First is the speed of light should be 3 into 10 to the power of 8 meters per second. The mass of the photon is not defined in Newtonian mechanics. This is the second point. Each photon has definite energy and definite linear momentum. Let E be the energy of the photon and P be the linear momentum. Now E is equal to mc square is known to us. What is E? E is the energy of the particle, m is the mass of the particle, c is equal to speed of light. If they say the mass of particle is almost equal to 0 or could be neglected, then the energy produced is 0. So we will take unit mass of the particle. Unit means 1 or some value which is lesser than 1 but definitely not equal to 0. The equation which is framed, E is equal to h nu. So E is equal to h nu means what? H is Planck's constant, nu is the frequency of particle, and E is the energy generated. So h nu could be equal to hc upon lambda. Then what is P? P is linear momentum. Then linear momentum can be defined as P upon lambda, which is equal to E upon c. C is again the speed of light. What is value of Planck's constant and unit of Planck's constant? 6.626 into 10 to the power of minus 34 joules second is value in terms of work for Planck's constant. And in terms of electrical parameters, it is 4.136 into 10 to the power of minus 15 electron volt second. These are the two parameters. Then how is the principle of law of conservation of momentum being followed by the photon? A photon may collide with a particle, with a material particle. The total energy and the total momentum remains conserved in such collision. The photon may get absorbed and a new photon may be emitted. Thus the number of photons don't remain same before and after collision. So conservation of momentum doesn't happen here, which comes from the Newtonian mechanics. This concept comes from Newtonian mechanics. If the intensity of light of a given wavelength is increased, there is increase in number of photons crossing a given area. in a given time. The energy of each photon remains the same. This also needs to be known. Then comes photoelectric effect. Now, what is the concept of photoelectric effect? In photoelectric effect, there is one effect which is called as photovoltaic effect. The second effect is called as photoemissive effect. Photoemissive effect is was just now explained to you all through photoelectric effect generally. This happens only when particles hit a metal surface with very high frequency. Then comes photovoltaic effect. What happens in photovoltaic effect? In photovoltaic effect, when light particles falls on semiconductors, especially on the p side, and the semiconductor has to be reversed bias, means p terminal is connected to a negative terminal of the cell and n terminal is connected to the positive terminal of the cell. Then in that condition you can see current flowing through the circuit. What happens exactly in this? When light particles fall on the window of the photodiode, then they replace the holes inside it. When they replace the holes inside it, then in that condition current is conducted through the circuit. Either you can connect this photodiode for making or you can for not making, for charging the cell, or you can use this photodiode to make certain other circuit run. There is a photo transistor which also works on the similar principle, but that I will teach you after studying the concept of your transistors NPN and PNP type, after studying the semiconductors chapter which is there in our study for standard 12th. Then we will start working upon the concept of work function. In the concept of work function, what happens? Kinetic energy and work function both are to be considered. Let monochromatic light of a certain wavelength lambda be incident on the metal surface in a particle picture. So the energy emitted is hc upon lambda, because lambda is the wavelength which is produced by the photon after collision with a free electron. The electron gets extra energy, E is equal to hc upon lambda. So the work function which you will get of the kinetic energy is kinetic energy is equal to hc upon lambda minus work function, which is the light energy function, which is equal to h nu minus of work function. If you write it in other way, you will get work function is equal to h nu minus kinetic energy of the particle, or it could be written as work function is equal to hc upon lambda minus kinetic energy of the particle. This is called as the Einstein's photoelectric effect, which was prior invented by scientist Hertz. This, you cannot say it as invention, you can call it as discovery, because this was already happening in the universe, only they patented it. This has been patented by Albert Einstein, a great physicist, and this theory was derived in 1905 when he was working as a third technical officer in his university and for the army of Germany. He was awarded with Nobel Prize in 1921 for his this kind of research paper. How will your wavelength become operational? When there is threshold wavelength. This is called as the minimum wavelength, which is required for producing the photoelectric effect. After that, there is an experimental arrangement which helps you to understand the effect of a photon. अरे कुठे जातात कुठे लेक्चर्स. Then we move further. What is threshold wavelength? This is the minimum wavelength required for producing photoelectric effect. The maximum wavelength which makes the circuit run is called as the wavelength which is responsible for producing the maximum frequency, or you can say this is the wavelength which corresponds to the maximum frequency produced. The threshold wavelength has a corresponding frequency. Firstly, the threshold wavelength is denoted by lambda naught, which is equal to hc upon work function. Then the corresponding frequency v naught is equal to c upon lambda naught, which is equal to work function upon h. Then work function is equal to h into nu naught. So the maximum kinetic energy produced is given by h into mu naught, not mu, nu naught minus nu, sorry, once again I am telling, kinetic energy produced is equal to h into nu minus nu naught. Okay, the experimental apparatus we will study, which consists of an cathode, a anode, and also a voltage source. First part, what photoelectric effect which we studied was based on semiconductors. Now this photoelectric effect and the photoelectric current is based on what? It is based on the effect which happens on metal surface. Here they have taken a cathode. Cathode is connected to negative terminal of the source. Anode is connected to the positive terminal of the source, that is voltage source. When light reasonably falls on the wavelength, what happens to that, when from a transparent window, electron is emitted from the cathode. The potential difference between the cathode and anode can be changed with help of batteries, rheostat, and a commutator which is externally connected. And also an ammeter is used in order to check whether the current is flowing through the circuit or not. Then when you come back to the cathode, see, a flow of current is being experienced when electron is being released by the cathode when light falls on it of very high intensity. This is called as photocurrent. As photoelectrons are emitted from the cathode, see, they move towards anode. At any time in the space between anode and cathode, large number of electrons are available. They space up the charge. Negative electrons repel each other when new fresh electrons come. Here, however, some electrons are able to reach the anode. There is photocurrent. That is why in semiconductors there is reverse connection. When anode is given a positive potential with respect to the photocurrent, with respect to the cathode, electrons are attracted towards anode and photocurrent increases. The current does depend upon the potential applied to the anode. The variation in current with the potential. If the potential of anode is increased gradually, a situation arises when effect of space charge becomes negligible and any electron emitted from cathode is able to reach anode. This concept is called as saturation of the current. The magnitude of this photocurrent is very low. This is the first part. Then we will try to understand the equation. The charge of electron into the potential difference available is equal to the maximum energy, kinetic energy, the photoelectric effect can produce or the photon can produce, which is equal to hc upon lambda minus work function. Now what is V naught? V naught is equal to hc upon V naught is the minimum potential difference produced between anode and cathode, which is equal to hc upon E, where h is Planck's constant, c is the speed of light, E is the charge of electron, then it is multiplied by reciprocal of lambda. What is reciprocal of lambda? Lambda is the wavelength minus work function upon the electric charge. Then there are graphs given in your book which are associated with saturation of current and rise in potential difference. As the intensity of the light changes, the stopping potential of the electron in the anode changes. Intensity of light I1 is smaller, I3 is maximum. When you try to make an angle of the stopping potential with help of wavelength, you will get an angle theta. This could be plotted with respect to the stopping potential is need is needed to be understood in this chapter. If we try to make the angle of tan theta, which is the angle made by the light with the surface, is given by tan theta is equal to hc upon E. These are the effects of the potential or the stopping potential difference which is being produced by whom? By a simple photon.